Hello and welcome everybody. Today we are going to be doing a topic called calculus, right? Um, we are going to be touching few of the topics situated with calculus for grade 12's mathematics. Um, this is the formula for the first principle, which is f of x plus h minus f of x. You see, most of the time I see learners getting it all wrong or getting it all fixed up. So we are going to tackle 2 to 3 examples that are taken from um, some few question papers. Um, the first example we are going to have is f of x equals to negative 3x squared. That is the first example. Then the second example will be f of x negative 4x squared. Then the third example will be f of x 2x squared minus 5. Now, if the question comes and says, find this, solve this using the first principle, or find the derivative using the first principle. So we are going to begin with number 1. That is f of x, which is equal to negative 3 x squared. I hope everything is clear and I hope everybody can see. Now, from the first principle, that means we need to find our f of x plus h, which is going to be negative 3x plus h squared. So it's going to be negative 3x plus h, x plus h, which is negative 3x squared plus xh plus xh plus h squared. Now we multiply everything by 3. So it's going to be negative 3x squared. This is 2, remember? So it's negative 6xh. Remember, this is 2. Minus 3h squared. So therefore, our f of x plus h is equals to negative 3x squared minus 6xh minus 3h squared. Now, since we have the f of x, which is negative 3x squared, we have to now take the formula, which is f of x, f derivative of x. Must never forget this. It's very important because that's the derivative. F derivative of x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now all we have to do is plug in. So I'll just equate it there. So I'll just equate it. So remember, this indicates the f derivative of x. So this is going to be limit as h approaches 0. Now we plug in our f of x plus h. That was negative 3x squared minus 6xh minus 3h squared minus our f of x, that's negative 3x squared, right, all over h. The limit as h approaches 0 of negative 3x squared minus 6xh minus 3h squared. This is plus. Since it's negative and negative, we get 3x squared all over h. Now from here, because it's very simple to do this, right? You will notice that this one and this one will go off. So f is equals to the limit as h approaches 0. Now, since negative 3x squared and plus 3x squared are gone, we are left with negative 6xh minus 3h squared all over h. I hope everybody is still following. The reason being I'm doing this is because it's one of the basics. It's like they have given you free gift. This is a free gift. This is a giveaway. So now f derivative of x as limit of h approaches 0. Now what we note here that is common is h. So we factor h out. Then you are left with negative 6x minus 3h over h. So the h will go off. Now f of x, derivative of x, is the limit as h approaches 0 of negative 6x minus 3h. If we are to substitute the value of h, that is 0, so we are going to be left with negative 6x minus 3, 0, which is equivalent to negative 6x. So the simplest way to do it again, it's very easy. I will take it to the top. F of x is equals to negative 3x squared. So if you want to confirm that this answer is correct, use the simplest rule of differentiation, which is dx dy or df of x over dx. So basically we are differentiating our function, or yes, it's our function. We are differentiating our function in terms of with regards to x. So if you are going to do that, that means we are going to derivate where there is x. So we are going to say 2 multiplied by 3, that's negative 6x, and then 2 minus 1. I don't know if you have ever learned this rule. Okay, when you differentiate f with regards to x, you have a x b. So it's going to be a times b x b minus 1. This is the rule that you should be using. So as you can see, you've gotten your free marks, but I'll go deeper on calculus as time goes by. So now we go to our second example, which is almost the same as the first example. Our second example says that negative f of x equals to negative 4, negative 4x squared, right? Now we do the same. We find what is f of x plus h, which is negative 4x plus h squared, right? If somebody can get the answer is going to be 4 times 2, that's negative 8x. That is the answer. We have to get this answer. If it happened that you don't get this answer, then definitely the problem relies with our mistakes, right? So the first thing that you can do for you to be able to master calculus is to do this. Whenever you are given a function, find the derivative before you even start with the first principle. You understand me? So before you start with the first principle, find the derivative using the derivation rules. Now our f of x plus h is negative 4x plus h, x plus h is going to be negative 4x squared plus 2xh plus h squared. So this is going to be negative 4x squared minus 8xh minus 4h squared, right? So now we substitute our first principal equation, that's the limit as h approaches 0 of f of x plus h minus f of x all over h. So what we do now is we just substitute. So the limit as h approaches is equals to our f of x plus h, that's negative 4x squared, minus 8xh minus 4h squared minus 4x squared all over h, right? This is going to be, remember we should get that answer. So our derivatives will be negative 8x. Now let's hope we get our answer there. We come and say the limit as h approaches 0, that is negative 4x squared minus 8xh minus 4h squared plus 4x squared. Where do we get the plus? When you multiply two negatives, negative 1 multiplied by negative 1 is equals to 1. That's good. I think my answer will be clear from there, so it's not important here. All over h. So this one will be off, so you are left with the limit as h approaches 0, negative 8x minus 4h squared over h. So now what is it? H is out, negative 8x minus 4h all over h. H is out, so you are left with negative, so you are left with negative 8x minus 4h, which we substitute as 0, so we get negative 8x. That is the answer. Now we focus, we come to our number 3 example. Our number 3 example, which is what? Our f of x is equals to 2x squared minus 5. Remember, when we are looking for x plus h, whenever we see x, we put an h. So if it happened that our x is in cube, that means our x plus h will be in cube. So if x is on fourth root, sorry, fourth, it's cube, no, cubic, something like that. Sorry, you see, same goes for, that means it will be, that's how it corresponds. So that means when we talk about f plus h or f of x plus h, basically where we see x, we put an h. So if it happened that we have an equation like this and there is no x attached to the 5, we're not supposed to be touching an h. That's where I've seen most of the learners doing a mistake. They will be attaching an h there, 5 plus h, which is wrong, because the moment you do that, automatically you're going to get, we can't differentiate the derivative of constant is equals to 0. So if you differentiate 1, what's the derivative of 1? It's 1, I mean 0. That's one thing that you should be knowing, because there is no variable attached to it. So it's 0. So now our f of x plus h will be 2x plus h squared minus 5. 2x plus h, x plus h minus 5. So this is going to be 2x squared plus 4xh plus 2h squared minus 5. So we substitute it into the equation. We get f derivative of x equals to the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus 5 over h minus, we shouldn't forget our function, that was 2x squared minus 5. Now we come, see if limit as h approaches 0, that is 2x squared plus 4xh plus 2h squared minus 5 plus, no, minus, because there is no negative here, so it's minus, sorry for that, 2x squared plus 5 all over h. So the limit as h approaches 0, this one, this one, this one, and this one are out. So you're left with 4xh plus 2h squared all over h. Limit as h approaches 0. So we factor h out. We are left with 4x plus 2h over h. We are left with the limit as h approaches 0 of 4x plus 2h. We substitute the value of 0 where we see h, we are left with 4x. So you can attest to it. If we differentiate the value of the function with respect to x, we get 4x minus 0, which is 4x. So that will be it. That is how calculus is.